Hello and welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is exponents, multiplying and dividing. So let's get prepared for today's lesson by getting a pencil, and we're going to need one with an eraser hopefully, and paper so we can take notes, and an optional calculator in case you want to check yourself. Don't forget to pause the video from time to time to answer the practice questions. That is the best way to learn, is to try the problems on your own after watching the lesson and then checking to see if you're correct. Also rewind the video if you need to review anything before trying to answer the questions. Okay, so before we get into the vocabulary, I'm Miss G, and we like to start our lessons every day by breathing in our nose and out our mouth 3 times, holding it in for a count of 3. As we do this, we want to try to get rid of any of those thoughts or feelings or anything that might be getting in the way of our learning. So just put those to the side. Try not to think about them right now until after the lesson. And this is going to help us kind of clear our heads a little bit. So let's go ahead and breathe in through our nose. Hold it for 1, 2, 3. Breathe out our mouth. Okay, one more time. Breathe in through your nose. 1, 2, 3. Breathe out your mouth. Okay, and the last one, breathe in through your nose. 1, 2, 3. Breathe out your mouth. Okay, and if you need to take additional breaths, or if you need to pause the video and take a couple of breaths in between, that's perfectly fine. All right, let's go ahead and look at some of this vocabulary. Our first word is, of course, exponent. What is an exponent? You can think of an exponent as like a shortcut for telling us how many times to multiply that number times itself, okay? So the exponent is just a little bitty number that's right, excuse me, to the right and above the number that we're multiplying. And that number is called the base. So the base is the big number here, and then the exponent is that little 2 right there. And that's telling us to take this 3 and multiply it 2 times, okay? Or 1 time, but 2 3s in the multiplication. So 3 times 3. If this was a 3 here, then we would do 3 times 3 times 3. And then a 4 tells us to do 3 times 3 times 3 times 3. So again, that number is telling us how many 3s we're multiplying there. Our next word is going to be power. That's another word that we use to describe an exponent. So we can read this expression here as 3 to the 2nd power, or we could say 3 to the exponent of 2. The base, of course, is the number that has the exponent attached to it. And we are going to talk about properties of exponents. Now, today's video is going to have the quotient of properties, the quotient of powers property, and it's also going to have the zero property and the product of powers property. Okay, so we're talking about quotients and products. So really that's multiplying, which creates our product, and quotient, which creates, which is a division problem. So basically, this is the property of our exponents that's going to explain to us how to multiply these exponential expressions or to divide them, okay? And the zero property we're going to also mention today as well. We're also going to talk about expanded form and exponential form. Exponential form kind of looks like this, and then expanded form is when we actually expand all of the numbers out. Reciprocal is when we take a fraction and we flip it around where the numerator becomes the denominator and the denominator becomes the numerator. And we also will probably mention negative numbers and positive numbers, because we are going to have some information about how exponents relate to negatives and positives, which are also integers, which are all of our whole numbers, positive and negative, including 0. And variables as well. Variable is a letter that we use to represent a quantity or a number. And we use variables quite often in algebra. Okay, our 3-lesson essential questions for today. Compare a power with a negative base outside of a parentheses with a power that has a negative inside of the parentheses. Provide examples of both situations. The second essential question is describe the product of powers property of exponents, or how do you multiply powers? The third one is explain the quotient of powers property of exponents, or how do you divide powers? Okay, so let's briefly talk about what are exponents. We mentioned this earlier in the vocabulary, but it's good to review. Exponents are a shortcut for repeated multiplication. Just like multiplication is kind of a shortcut for repeated adding, a exponent tells us how many times to multiply a number times itself. Okay, so we have a couple of examples here. 2 to the third power is the same as saying 2 times 2 times 2, because this 3 is telling us to write that 2 3 times and then, multiply them all out, and 2 times 2 times 2 ends up being 8. 5 to the fourth power is 5 times 5 times 5 times 5. So again, there's 4 5s here that we're multiplying together to get the 625. Exponents shorten having to write out long expression of factors. So when we have 2 to the third power or 5 to the fourth power, that's a little bit easier to write than all of this. Okay, the parts of an exponent, the small number to the right and up above is the exponent itself. The base is the number that the exponent's attached to. We also call the exponent a power, so I would say 5 raised to the power of 3. And a lot of people make the mistake of taking the base and multiplying it times the exponent, and that is never what you should do. So, so if you're in the habit of doing that, that's a bad habit. You need to break that habit. 5 should not be multiplied times 3. This is merely telling us to write 5 3 times and multiply those out. Okay. Okay, so here's an example of the difference between exponential form and expanded form. So exponential form would be like this, 5 to the fourth power. Exponential form contains exponents. Okay, expanded form is when we expand it out, we actually list the numbers out like we do here. Okay, so sometimes they will ask you to write your answer in exponential form, and then sometimes they will ask you to expand it out. Okay, so just keep that in mind. All right, so what do we do when there's no exponent, right? So when there is no exponent showing next to the base, then the exponent is a 1. It is often not necessary to write the 1 exponent. If the number or the base stands alone, then it will have an understood exponent of 1. So let's look at some examples here. 8 to the power of 1 is the same as just 8. Okay, now we don't have to write this 1 here. So most of the time you're just going to see an 8 by itself. And so it's understood that if there's an 8 there, there is an exponent of 1, even though we aren't required to write it. Okay, same with 7. 7 here is the same as 7 to the power of 1, or with an exponent of 1. Again, we aren't required to write it, but sometimes it helps when you're learning how to do operations like multiplying and dividing with these exponents. Okay, and what if the exponent is a 0? Okay, so 0 and 1 is very related when it comes to this. So any non-zero number raised to the power of 0 is equal to a 1. Now that doesn't mean that the exponent's equal to the 1. The exponent is 0. That means everything changes to a 1. The base, the exponent, everything. So 8 to the power of 0 is 1. Negative 67 to the power of 0 is 1. The square root of 2 raised to the power of 0 is 1. 0.36 raised to the power of 0 is 1, and so forth. All of these are 1s except for 0. 0 is undefined. You cannot raise the power of 0 to a power of 0. Okay. All right, so let's look at exponents and parentheses. Okay, this is one of those things that tends to trick people sometimes. So we want to make sure we go over it so that we understand how this works. powers or exponents can have both positive and negative bases, okay? So sometimes when there is a negative in front of the base, it is located inside of a parentheses. And if the negative is inside of a parentheses, the answer will be different than when it is not in parentheses, okay? So we have an example here where the number does not have a parentheses, but there is a negative here on the base. So what this is telling you to do is, it's the same as saying negative. Here, let me change this to a point, to a pen so I can write this out. It's the same as saying -1 times a 4, because we know -1 times 4 is -4, right? So that's kind of like the same as saying -1 times 4. So when you're writing this out, you're writing -1 times 4 times 4 again, okay? And that's going to end up being -16, okay? Notice that when there are no parentheses, the answer will always be negative. So if your base is negative and there's no parentheses there, your answer will be negative, okay? However, when the example here has parentheses, your answer could be positive or negative, okay? So let me, okay, and it's important for you to know the difference so that when you have the correct sign, that you'll have the correct sign on your answer. Okay, so -4 in parentheses to the second power. Now we are squaring both the negative and the 4. Up here, we only squared the 4, and this -1 kind of got left to the side, okay? Here, we're squaring all of it. So we're going to end up doing -4 times -4. And of course, when you're multiplying and the signs are the same, you end up with a positive answer. So this one ends up being positive 16 instead of -16. Now, do you see how this and this almost looked like the same problem? But that parentheses made an entire difference in the answers, okay? This was a negative and this ended up being a positive. Now, just because there's a parentheses doesn't mean the answer will always be positive. Sometimes the answer is negative. So if I cube this -4 here, which is multiplying it times itself 3 times here, you're going to have a -64. So -4 times -4 times -4 is -64. So the parentheses doesn't always end up being positive, but if the exponent is negative, or excuse me, is odd, then your answer will be negative. If your exponent is even, then your answer will be positive. So that's one of those things where without multiplying it out, you can kind of look at it and say, oh, well, this has got an even number exponent. It's in parentheses, so I know my answer is going to be positive. This has got an odd number exponent, and my base is in parentheses, so I'm going to have a negative answer. Okay, now let's look at the product of powers rule. So this is the rule that tells us how to multiply numbers that have exponents with the same base, okay? Now this only works if the bases are the same, okay? So if I had a problem here that said 2 to the 5th power times, I don't know, 4 to the 3rd, that would not be the same base, so this power rule would not work, okay? So product of powers rule states that to multiply powers that have the same base, keep the base, and simply add the exponents. So yes, we are multiplying these numbers, but yet we're adding the exponents to get our answer. Now this is just a way to do this quickly so that you don't have to expand things out and then replace them into exponential form. This is a quick way to do it. So let's look at some examples. 2 to the 5th power. This is this example here. I'm just showing you over to the right here how it expands out to the same answer. So like 2 to the 5th power times 2 to the 3rd, we kept the same base and we added the exponents to make 2 to the 8th. Well, let's check to see if that's actually right. So 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. And then 2 to the 3rd power is just 2 times 2 times 2, which is 8. Now if I take 32 and 8 and multiply those, I get 256. So the answer should be 256 if I actually expanded it out. And 2 to the 8th, 2 times 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 2 is 256. So yes, it does work out correctly. So just remember, if you're multiplying exponents with the same base, you just simply add those exponents together and it'll give you the correct answer. Variables can also use this rule. So again, if you get a question with the same base and they're both like the letter B, just simply add those exponents and you'll get the correct answer. Now let's look at division. So quotient of powers rule, same thing. This only works if the terms have the same base. So divide powers that have the same base, keep the base, and this time subtract the exponents. Now when we do the subtraction, we need to go from top to bottom. If it's written in like a fraction form here, we know fractions can be division problems, right? So 5 to the third power divided by 5 to the second power. So that's basically 3 minus 2 if we use this rule. And that's going to give us 5 to the 1 power, which is the same as 5. Let's look at some more examples. 6 to the fourth power divided by 6 to the third. Keep the base, subtract 4 minus 3, and you end up with a 1. There should be a 3 there. That's a typo. And 6 to the 1 is the same as 6 when you simplify it out. Now here's one that's not simplified, and I'm going to go over that in just a minute about why this one's not simplified. The reason it's not simplified is because it's a negative exponent. We do not like to put negative exponents in our answer. For this video, I have left the negative exponents where they are because you're going to watch this video before you watch the negative exponents rule video. So I'm not going to go into how to remove that negative in this video. However, there is a way to get that -3 to go away and to become positive. And we'll talk about that on the negative property of exponents video. So again, we kept the base. The 7 is the same base. And this time we did 5 minus 8. And 5 minus 8 is a -3. So that is our answer. It's just not simplified yet. And then we have 9 to the 6th power divided by 9 to the 4, which is, again, keeping the base, subtracting the exponents. 6 minus 4, go from top to bottom when you do that subtraction. And that gives us 9 squared. And if we expand that out, it's 9 times 9, or 81. And then we can use variables as well. A to the 6th power divided by a to the 7th. Again, 6 minus 7 is a negative number. So this is the answer. It's just not simplified yet. You can watch the negative property of exponents video to find out how to simplify that. Multiplying and dividing powers can create negative exponents. So using the product of powers rule and the quotient of powers rule can cause negative exponents to be in your answer. A simplified exponential expression will not contain negatives due to the negative exponents rule. That should say negative exponents here. It may have negative numbers. It just will have negative exponents. And then for today's lesson, we'll be leaving in the negative exponents and the answers. So they won't be completely simplified, but really we're just doing that to learn how to multiply and divide and not worry about the negatives at this point. Okay, so now it's your turn to try and grow a blossom. So find the product and write your answers in exponential form. That means we're not going to expand it out. We're just going to write the answers with an exponent attached, okay? So I'm going to ask you to pause and I will count to 3. 1, 2, 3. Okay, for the first answer, we have 7 to the 9th power. Again, we added the 6 and the 3 together to get this 9. And for the next one, we have 3 to the 10th power. Again, we added the 8 and the 2 to get our 10 here. Okay, time to grow a second blossom. This time we're going to find the product and write our answers in exponential form. Do not simplify if you get any negative exponents. So again, if you get a negative exponent, it's okay, but we're not going to simplify that out just yet. So I will pause and ask you to try to answer this on your own. 1, 2, 3. Okay, so the first answer is m to the 16th. Again, we kept the base, and since it's a multiply problem, we add the exponents. 8 plus 8 is 16. And again, 12 to the negative 2. We kept the base 12, and we added 5 plus negative 7, which ends up being negative 2. We left our answers in exponential form because that is what our instructions say. Let's try to grow a third blossom. This time we're going to find the quotient and write our answers in exponential form. And again, if you get negative exponents, don't worry about it. Sometimes that'll happen. 1, 2, 3. All right, our first answer is 3 to the 6th power. So 10 minus 4 is a 6, and we kept that base the same at 3, okay? 5 divided by 5, keeping that base of 5, we're going to subtract 4 minus 9, and 4 minus 9 is a negative 5. Okay, our fourth blossom, find the quotient and write your answers in simplified form. So this means we're going to expand it out when we get our answer. Okay, so let's go ahead and try that. Go ahead and pause, and I'll count. 1, 2, 3. All right, so again, we add our exponents. Negative 2 plus a positive 2 gives us a 0, and we know that any number to the power of 0 is just a 1. So this 13 converts into a 1. So you had to remember your 0 property of exponents to answer that one properly. And then the last one is, again, 14 minus 14, because we are dividing here. Up here we multiplied, so we added. Now we're dividing, so we're subtracting these exponents, and 14 minus 14 is another 0. And so that letter or variable just becomes a 1, because anything to the power of 0 is equal to 1. Okay, let's try to answer our first pause and answer the essential question for a blossom. Compare a power with a negative base outside of a parentheses with a power that has a negative inside of the parentheses. Provide examples of both situations. So go ahead and pause and try to answer this one. All right, when a power has a negative right next to it, but there is no parentheses, the product will be negative. When a power has a negative inside the parentheses, the product could be positive or negative, depending on whether the exponent is odd or even. If it has an odd exponent, the product will be negative. If it's an even exponent, the product will be positive. Here's some examples without parentheses, and here's an example with parentheses. All right, our second pause and answer the essential question. Describe the product of powers property of exponents. How do you multiply powers? So try to remember the rule for multiplying an exponential number or an exponent times an exponent. All right, let's see. To multiply powers that have the same base, add the exponents. And so we're going to keep that base and just add the exponents. Our third question, explain the quotient of powers property of exponents. How do you divide powers? So go ahead and pause and try to answer. Alrighty, to divide powers that have the same base, subtract the exponents. So keep that base the same, but subtract the exponents to get your final answer. All right, so we're here at the vocabulary review, and this time this cute little hummingbird is going to help us out. Exponent is basically shorthand that tells us how many times to multiply a number times itself. The power is another thing that we call an exponent. So if we have 2 raised to a power of 5, that means we need to multiply 2 times itself and write out that 2 5 times. The base is the number that the exponent is attached to. The quotient of powers property states that when we divide exponents with the same base, we subtract those exponents. The product of powers property states that when we multiply exponents with the same base, we add those exponents. Okay, the zero property states that any number that has a exponent of 0 is just equal to a 1. Okay, expanded form is when we actually multiply out all of our factors, and exponential form is when we leave the base and the exponent attached to it. A reciprocal is when we take a fraction and flip it upside down. This is going to be important when we start learning about negative exponents. Okay, negative and positive. Negative is on the left side on a number line and positive is on the right. And integers are all of our whole numbers that are positive and negative, including 0. Variables are letters that we use in place of quantities or numbers that we don't know the value of. All right, so great work on exponents and learning how to multiply and divide them that have the same base. A bouquet of math blossoms has opened up in your mind this time for exponents. So to further improve your math language skills, remember to practice by doing your classwork as much classwork and homework as you can. Study 10 minutes daily and ask for help if you need to. Now that doesn't mean you have to study only 10 minutes daily. That means, at a minimum, if you're trying to learn math, you should, review what you did the day before, or try to set up some kind of schedule where you're studying a little bit every day so you don't forget anything. And then learn from all of your mistakes, because we all make them. I make them all the time. I just try not to repeat them, okay? And always try and never give up. So show some perseverance and in solving these problems, and it will definitely make you happy when you finally do. All right, I'm Miss G, and I want to thank you for watching today's Math Blossoms video. The next video on exponents in this series will be power of a power rule. So that means we are raising a power to another power. So that's the one I would recommend you watch next. And now it's time for me to say it was lovely teaching you math today. Bye.